Here's my tutorial for Positive Chemistry 14. Let's do some questions. The basic idea here is that balancing equations makes all the atoms on one side be the equal number on the other side. We don't lose any atoms. If they go in, they must come out. So here's our little visual. We have two lithiums on the left side of the arrow. All of these become all of these. They're just rearranged is all. These are the same exact atoms on both sides. It's not just the same numbers, it's the exact same ones, just rearranged. So we have 2 on the reactant, that's the left side, and then 2 here. Over on the product side, we have 2 and 4 oxygens on the left side, and then we have 3 on the right. Oh, sorry, we have 4 and 5 oxygens on the left side, don't we? And then we have 3 on the right side. So this is not balanced correctly, is it? Already we know the answer is no. We have 2 carbons on the left and 1 on the right, 2 on the reactant and 1 on the product. This is not balanced correctly, and we are right. Let's try another one. I have 1, 2, 3, 4 N's, just to pick something, and I have 1, 2, 3, 4 N's. That's true. That works. How many lithiums? 1, 2, 3, 4. And then 1, 2, 3, 4. That works. And then how many oxygens? This is 3, 6, 9, 12. And then 12. This was that 8, 9, 10, 11, 12. Well, that did work, doesn't it? So since they match from here to there, all the way down in all 3 cases, it is just a rearrangement. Everything does make sense. You can't put in 12 though and get out 19 or something. The numbers need to match. So is it balanced correctly? Yes. Let's go to version 6, unit 6. So what we have here is 2 of SO2. So we have SO2 twice. So we have SO2, SO2 twice. That is 2 S's sulfurs on the left side. On the right side though, I only have 1, because that 3 only goes for that O. So I only have 1 on the right side. So I know already that it's not balanced correctly. Watch. See? The O's on the left are 1 and 2 sets of 2, or 2 sets of 2. There we go. So that's 4, and the other one is 5 on the left, and that is just 3 on the right. So that's another reason that these don't match, and these are not balanced correctly. This person did a wrong job. On the left side, I have 2 H's, and on the right side, I have 2 H's. So that does match, but the fact that the other ones don't, the O's don't match, and the S's don't match, means that this is an incorrectly balanced equation. On the left, I have 4K, that's potassium. And on the right side, I have 2 sets of 2, and on that's right, that's 4 then. Okay, that does work. N is, now remember, the inside of all of this is 1K, right? But I have 4 of them, 4 sets of this molecule, or this ionic compound. So I have 4 N's, and over here I have 4 of that one. So there are also 4 N's. Over here I have 4 sets of 3 O's. That is 12. Over here I have 2 sets of 1 is 2. 4 sets of 2 is 8. 8 and the other 2 is 10. Plus this 2 is 12. So everything does match. It is balanced correctly. Let's go to number 7. So at this point, we got to balance these out ourselves. So let's pick the biggest number to attack, or the biggest mismatch we can find. Actually, H is not a mismatch. Let's zoom in there, shall we? Because that's 2 and that's 2, so that doesn't really help me. what I've got a mismatch on here is 1 O and 2 O's. And I remember I can only multiply them. Some kids say then I'll have half of this, but we deal in whole numbers. If you break up oxygen O2, it's not the same molecule, and that's cheating. First of all, it would be very hard to do. Second of all, it would probably just reform if you did it. So for both reasons, we don't get to do that. So what we can do is have multiples. I have 2 over here and 1 over here. So let's double this one. And then I have, sorry, wrong one. Here, let's double this one. And then I have 2 here. We'll keep a 1 there. 1 set of 2 and 2 sets of 1 O. And now that matches. So then I have 2 O's on both sides. The H's changed though. Always ask yourself, and then what changed? What changed then? I have 2 sets of 2 H's is 4. I have 4. I need 4. That would be 2 sets there. 2 sets of 2, that gives me 4 on both sides, and I'm right. Let's try another one. Okay, these are all pretty simple ones. That's good. They're stepping us up. Here, let's try this one though. That is S8. For reasons that I never was really told, sulfur by itself sometimes occurs in sets of 8, but we have 8 of them. So if I have 8, I need 8. Let's do 8. What just changed? Calcium. How much? 8. So this needs to be an 8 there. Oh yeah, a 1 there. So I have how many calciums on both sides? 8. How many sulfurs on both sides? In this case, weirdly, it's both 8. And we're right. Oh, I forgot to cut the 8. There we go. And we're right. Let's go to the next section. So I see 2 rubidiums and 2 rubidiums on both sides. That doesn't really help me. 1 carbon and 1 carbon. That doesn't really help me. And 1, 2, and 1 is 3 O's. And you know what? This is a real simple one. This is a trick question. Everything is already matching. We need 1, 1, 1 of everything. And I was right, which leaves us with 2 rubidiums on both sides, 1 carbon on both sides, and 3 oxygens on both sides. And we were right. Okay, this means 2 of both O and H. So I have 2 O's and 2 H's on the left side. I also have 1 and 2 O's on the right side. That matches. 2 H's on the right side. That matches. 1 strontium on the right side, 1 strontium on the left side. This is also already set up to be all 1s, right? Which leaves 1 of these and 1 of those, and 2 of these and 2 of these and 2 of these and 2 of these. Here's one that threw me a curveball, and I actually had to stop and think about it. I have 2 K's here and 1 here, so I'm going to double this one. So these numbers here and here can't match because I need this to be probably a 1. At least they can't match. Let's see what we get now. We have 2 N's, and then that makes me want to put a 2 there. What do we have on the left side? 2 K's, 2 K's, 2 N's, 2 N's. Now, how many oxygens? 2 sets of 3 is 6, and this is 2 sets of 2 is 4, and another 2 is 6, and that one's 7. Okay, this gets a little tricky. What we can do then is usually double everything you just said, and oftentimes that gets you out of your problem. Let's go back and do that. Let's say 4 and 2 and 4. The other clue is that I had an even number and an odd number, and it doesn't matter which side, but you can't get an odd number to multiply to be an even number unless you cheat with fractions and stuff, which we can't do in this. So go back and double everything you just said and make sure that the thing that was odd is now even. This O was a single O and it was odd. So I doubled it and now it is even. Let's see where that gets us. I now have 4 Ks. 2 sets of 2 is 4. 4 Ns. 4 sets of 1 is 4. This 4 sets of 3 O's is 12. This is now 4 sets of 2 is 8. Another 2 is 10. And this 2 makes it 12. And we are right. Which leaves 4 and 4 and 4 and 4 and 12 and 12. So the biggest thing I see here, what's out of whack? What's out of whack? I see that chromium has 3 and then chromium has 1. We could attack that maybe. But you know what I like to do is attack the 3 versus 2 mismatch even more because it usually saves me time. If we have 2 and 3, then we need 2 of these and 3, sorry, 2 and 3, right? I need 2 of these and 3 of those. So let's put a 3 here so that we have 6 lithium and 2 there. So we have 6 lithium. Let's attack everything else now. I have 2 Ns and 2 Ns. Hey, that fixed that. I have 3 chromiums and this is going to need a 3. But you know what? I fixed the selenium by accident and that's a very good sign. And I'm probably right. Overall, I'm probably done and I'm almost assuredly right. So this is going to be a 1. Notice I have 3 chromiums, 3 sets of 1 chromium there. And then I have 3 seleniums. And then this 3 fixed my selenium over there kind of by accident. I wasn't even thinking about it. And then how many do we have? We have 3 chromiums and 2 nitrogens and 6 lithiums and 3 seleniums. And we're right. Do we see any 2-3 mismatches? No. So what does mismatch? The bromium over here is a 2. And then this is a 1. So I'm going to try putting a 2 here and a 1 here. 1 magnesium, 1 whatever the group that is, selenate or something. 1 selenate group. 2 H's, 2 H's. So this all works. We were right. 1 magnesium, 2 bromine, 2 H's, and 1 selenium and 4 oxygens. I see that the nitrate group here is 2, and that's 1. So let's put a 2 here. What just changed? Hydrogen. How many? 2. So that puts a 2 here. What just changed? Fluorine. How many? 2. So let's put, oh, that already is 2. So let's keep that as a 1. What did we just change a bit? Cobalt. How many do we have? 1. How many do we have here? 1. Oh, so let's keep that. And we're right. And so we have 1 cobalt, both sides, and 2 F's, and 2 H's, and 2 N's. And remember that we have 2 sets of 3 oxygens, that is 6 on both sides. All right, so here's the more difficult part. We're going to use the English names that were provided. We know it's bromine, and look at your periodic table. We know that is Br2 because it's diatomic. It's magnesium oxide. That's a +2 -2, so it's 1 of each. And magnesium bromide is a +2 - 1, so we need 1 and 2 of them. And oxygen. And oxygen has the star in my periodic table, which means it's diatomic, which means that there are 2 of them. And then we can balance it. This is balanced for bromine, 2 and 2. You can't highlight that. And 1 magnesium, that doesn't help. But we have 1 oxygen on the left there and 2 there. So we're going to have to double this one. Now the oxygens match. What just changed? Magnesium. How many? 2. So let's put a 2 here. What else just changed? Bromine. How many? 2 sets of 2 is 4. So we're going to need 2 sets of 2, making 4 over there. And this can remain a 1. And we're right. And that leaves, remember, 4 bromine and 2 magnesium and 2 oxygen. Aluminum oxide is a +3 - 2, so we're going to need 2 and 3. And with water and aluminum hydroxide, aluminum is a +3. We have a -1, so we're going to need 1 and 3. And 3. What's out of balance? Well, I see the aluminum is a 2, so that's probably got to be a 2 there. In every one of these, there is 1 H. Then we have 3 sets of that. That is 3. But we have 2 sets of that, which is 6. So I have 6 H's. So I think that is a 3 there. Same goes for the oxygen on the right side. So we have 6 oxygens over here. And then we have 3 sets of 1 is 3. And another set of 3, that is 6. So yeah, we're keeping that one there. Which means we have 2 aluminums. And we said 6 oxygens. And 6 hydrogens.